Everything we see, from the smallest ant to the largest star, is made of matter. Matter is made up of atoms, the building blocks of everything. But the matter we see is only a small fraction of the universe. There's something else out there, dark matter. Like a cake needs unseen flour, the universe needs dark matter. Dark matter is invisible to our telescopes, but we see its effects on stars and galaxies.
One of the biggest clues for the existence of dark matter comes from how galaxies rotate. Galaxies, those massive collections of stars, gas, and dust, are constantly spinning. If we only consider the visible matter, the stars at the edge of the galaxies should be moving much slower than those near the center. Think of a merry-go-round. The horses on the outer edge travel a much larger circle than those near the center in the same amount of time. This means they are moving faster. However, when astronomers measured the speed of stars in galaxies, they found something surprising. The stars at the edge were moving much faster than expected, almost as fast as those near the center. This unexpected speed is a bit like watching the merry-go-round and seeing all the horses moving at the same speed, regardless of their distance from the center. It just doesn't make sense unless there's something else, something invisible, providing extra gravity to hold those fast-moving stars in their orbits. That something else is dark matter.
Another piece of evidence for dark matter comes from a phenomenon called gravitational lensing. Einstein's theory of general relativity tells us that massive objects like galaxies and clusters of galaxies can actually bend the path of light that passes by them. This bending of light acts like a cosmic magnifying glass, distorting and brightening the images of distant objects behind them. Imagine looking at a distant streetlight through a wine glass. The stem of the glass will distort the light, making the streetlight appear brighter and possibly even changing its shape. Gravitational lensing works in a similar way, but on a much grander scale. By studying how much light is bent and how these background objects are distorted, astronomers can calculate the amount of mass present in the lensing object. What they found is that there's much more mass than we can see in the form of stars and gas. This discrepancy between the visible matter and the gravitational effects points towards the presence of dark matter.
Section 4. Unmasking the Invisible. The Hunt for Dark Matter Particles. Scientists are actively searching for the elusive dark matter particles. While we know dark matter exists through its gravitational effects, we still don't know what it's made of. Current theories suggest that dark matter is made up of particles that interact very weakly with ordinary matter, making them incredibly difficult to detect. One leading candidate is a type of particle called a WIMP, or weakly interacting massive particle. These hypothetical particles are thought to be much heavier than protons and neutrons, the particles that make up atoms, but they would rarely interact with normal matter. Scientists are using various techniques to try and detect these elusive particles. Some experiments are looking for faint flashes of light that would be produced if a dark matter particle collided with an atom in a detector deep underground, shielded from cosmic rays. Others are trying to create dark matter particles in particle accelerators, like the Large Hadron Collider, by smashing protons together at incredibly high energies.
Section 5. Dark matter's place in the cosmic puzzle. Dark matter is a crucial part of our understanding of the universe. It plays a vital role in the formation and evolution of galaxies, holding them together with its gravitational pull. Without dark matter, galaxies would fly apart due to the high speeds at which stars and gas are moving. It also plays a significant role in the large-scale structure of the universe. The cosmic web, a vast network of filaments and voids that make up the universe, is thought to have been shaped by the gravitational influence of dark matter. While we still have much to learn about dark matter, its discovery has revolutionized our understanding of the cosmos. It reminds us that there's still so much more to discover, and that the universe is full of mysteries waiting to be unraveled. The search for dark matter is a journey into the unknown, a quest to understand the fundamental building blocks of our universe and our place within it.